To today's webinar, Enhancing Cybersecurity Operational Performance, Challenges and the Role of AI. I'm Andreas Föhringer from Logpoint and I'll be your host. Today's session will explore the real-world challenges that modern cybersecurity operation centers, MSPs, MSSPs, and in-house IT teams face, from alert overload to skill shortages to evolving threat sophistication, and how artificial intelligence and machine learning are transforming how cybersecurity teams detect and respond to threats. Joining me is Javier Schmor, lead data scientist at AISOC, a company at the forefront of applying AI in cybersecurity operations. AISOC's platform is designed to enhance cybersecurity teams' performance through advanced AI and machine learning, analytics, automation, and intelligence-driven workflows. Welcome, Xavier. Great to have you.
Thank you, Andreas. Thank you for this introduction. So at AISOC, as you mentioned, we are focusing on leveraging AI and machine learning to help organizations moving from reactive security to proactive defense. And really over the past couple of years, we've seen a lot of advances in how AI can support cybersecurity teams, from accelerating the detection to also reducing the alerts fatigue. So we know that there is a lot of hype and fears surrounding AI and generative AI. So at AISOC, our aim is really to develop and provide a robust and trustworthy cybersecurity capability.
That's very good to hear. And that brings us kind of on what we want to cover today. So first of all, we need to talk about the key challenges faced by modern cybersecurity teams. And then we go to the role of AI and machine learning in addressing these challenges. And then real world applications and benefits seen with AI SOC. So what you have actually done. And last but not least, how to get started and best practices for adoption.
Thank you. So yeah, let's start with the challenges that are faced by cybersecurity teams. So first off, we know that there are more and more advanced alerts or threats that are being generated. So they are just more sophisticated. We know that attackers are now using generative AI more and more in order to perform cyber attacks. There are also way too many alerts that have to be investigated by cybersecurity analysts. So due to this overwhelming number of alerts, that's creating cyber analyst burnout. So we are really conscious that this is something that is hard for cybersecurity teams. We also know that there are not enough cybersecurity analysts in the market today. So not enough people are as skilled and can respond to threats, making scaling difficult, but also making handling the current operations harder. We've also seen with some of our partners that tools are very fragmented. So one security analyst might have to look at many different dashboards or many different security platforms. So the data reside in different solutions, and that can slow down investigations when a security analyst has to jump between different solutions in order to investigate an alert. We've also seen that MSPs and MSSPs have limitations in terms of capabilities. So we've got the statistic that says that about 80% of the organizations rely on providers that don't have enough SOC capabilities or just don't have a SOC capability for different reasons. Like it could be the cost, or it could just be manpower is not available. And all of these lead to delayed response, potentially missed incidents because cybersecurity analysts are just overwhelmed with alerts, and of course an increased risk exposure. So moving on to what we mean by AI these days, because we hear AI a lot in the market, but what does AI even mean these days? So traditionally, I mean, 2-3 years ago, before generative AI was a big thing, we used to see AI as machine learning mostly. So in terms of use cases, machine learning could be, for example, used to improve threat detection. So we have a common use case that's using regression models, looking at time series data in order to detect anomalies. So that's one use case. There is also another use case related to improving the identification of threats. So classify the alerts and identify malware or phishing attempts quickly. And the problem with machine learning solutions is data that's ideally labeled, since machine learning models that make a prediction on whether, for example, an alert is suspicious or not need labeled data, and you need also a lot of time in order to train those models to make accurate predictions. And there are a lot of solutions out there, a lot of machine learning models, a lot of methods, and in the market we know that there is no silver bullet, meaning that not a single solution would tackle every possible use case. So when using machine learning, you need to be conscious that you would need to develop different models that would tackle different use cases. So now moving on to generative AI. So in the past, I guess, couple of years with ChatGPT, Copilot, and others, we've seen really great opportunities in using AI in cybersecurity. So, for example, one use case is the summarization of complex data, because when a cybersecurity analyst is looking or trying to investigate thousands of logs or hundreds of alerts, it's just humanly not possible to read all that information. And another use case is the suggestion of remediation steps and drafting emails that are, for example, tailored to a specific audience. So that can be used again by cybersecurity analysts to share information with their team easily. However, in terms of requirements, like machine learning models, they can be quite heavy, since we know that, well, if you don't have integrations between your large language model tool or the large language model that you are using with existing software or with knowledge bases, it can be complicated to get accurate answers. So yeah, one of the keys is really to try to integrate your large language models with existing tools and knowledge bases, or feeding those data to the LLM. However, there are, of course, concerns around whether you should host those LLM on-prem, which would come at a cost in terms of GPUs, or if you can leverage an existing LLM solution, which could be then hosted in the cloud. But then with LLMs hosted in a cloud, you would have further considerations related to the sensitivity of the data that are passed to the large language models, which needs to be taken into account. So moving on now to the role of AI in enhancing cybersecurity teams. We know that, there are a lot of risks, as I mentioned, related to AI. So both machine learning and large language models. So models can be biased, so based on the training data, or based on how those models were learned or were trained. For example, we've seen that with large language models and with machine learning models, there could be concerns around the privacy of the data that are fed to. So, for example, if you are feeding private data to the large language models, those private data could come out when being used by users that shouldn't see those data. We also know that there are adversarial manipulations. So we could think, for example, of a scenario where an attacker would perform an attack on a network, and then within one of the logs, he could have some information hidden, like a message saying that this is genuine activity, like this is not this is not a cyber attack. And then the machine learning model, or actually the LLM in that case, could understand this as the truth, and as well, okay, I'm just gonna ignore this alert since it's telling me that it's not a cyber attack. So yeah, we could think of examples like this where logs contain malicious information, or where the models are being poisoned. So moving on to the controls that can be implemented to limit those risks. So of course, well, one of the main approach that defenders can use is, well, the transparency, in which models, the output of the models are generated. So when all the information that's used by a large language model is clearly explained, that's where it can provide great outputs. In terms of machine learning, there is what's called, well, explainable AI, which can again provide information about how a machine learning model made a prediction. And with large language models, responsible AI principles and guardrails can be set up. So for example, all the information that's going to an LLM, so the input of an LLM can be analyzed by another LLM, like a smaller LLM could filter the data that's fed to a large language model, and same with the output of a large language model. So before a large language model sends its output to a user, you can have a smaller model that actually checks the output of the large language model to make sure that it's sanitized and it doesn't have any sensitive data, private data, or that it doesn't have any data that could be harmful to the user. So if we take a step back and remember the objectives, because I've been talking a lot about AI. We want to augment the analysts, so we don't want to replace analysts, because we do believe that analysts are still an essential part of the workflow. But yeah, we want to accelerate the pipelines and the workflow that analysts have to go through, and we want to improve the accuracy of the predictions that are made by analysts, but also by machine learning and large language models. So we've built a very simple table here based on requirements from an organization and a solution that we recommend. So in summary, if you're looking at predictive analytics and you have historical label data, machine learning is one way to go, or is the recommended way to go. However, if you want natural language explanations and interacting with a large language model and summarization capabilities, that's where generative AI is more helpful. And of course, well, best of both worlds is if you want both the predictive and the conversational capabilities, so analysts to interact back and forth with a large language model. That's where a hybrid approach can be helpful. So using both machine learning and large language models. Now, of course, an hybrid approach could maximize the flexibility and the operational impact. And the choice, well, it depends on the data maturity. So if an organization doesn't have a high data maturity, so doesn't have, let's say, historical cleared label data, machine learning might not be the right approach. But if an organization has those, then machine learning could be a totally valid approach. And yeah, it depends, of course, on the goals of the organization.
Yeah, I mean, you touched upon a lot of things there. What really stands out is that when you apply this AI parts to the solutions or into the process, actually, integration is key. So by connecting those AI-driven analytics from AISOC with Logpoint CM and SOA capabilities, organizations can actually achieve end-to-end visibility and faster data-driven response as an overall outcome, correct?
Yes, yeah, exactly. Agreed. And actually, that's something we've got some experience in, because now we're going to touch on a real world application and some of the benefits that we've seen from it. So over the past 2-3 years, we've been working with Logpoint actually since 2021, so it's been 4 years already. So we've been working with Logpoint on this solution called AI SOC. So MedCloud is a UK-based MSSP. So I'm part of MedCloud, but we've developed a solution called AI SOC. And we started working on AI SOC about in 2021. And at the time, we were using another SIEM, but the data that we were getting out of the SIEM and out of the SOC that we were using at the time were quite messy, or there was not much clarity. And it was really hard also to extract the data from that SIEM. So it was really hard to integrate it within our platform. So we've moved to Logpoint around 2021 actually. And since then, we've collaborated with Logpoint, and we've also a third-party SOC team that was based in Northern Ireland, and with academics from Birmingham City University. And what we've developed is, first, a capability to a capability to automatically retrieve SIEM incidents from Logpoint and all the related logs using the Logpoint API. And we are correlating all those incidents, all the alerts, using what we call a risk-based calculation, so some statistical approach in order to make a prediction based on a variety of indicators. And so some of the indicators would be based on AI and machine learning models. So that's where we leveraged AI and machine learning models based on historical data. So since we've been working with a SOC team, we do have labeled data. So what we mean by labeled data is we know which past alerts have been investigated and labeled as suspicious or non-suspicious, or as we don't know, unknown. And so that's something that we're using in our platform in order to make a prediction. We also generate what we call contextualization information. So that's in order to explain the prediction made. So again, for the concepts related to transparency, which we also currently are integrating with generative AI, large language models. So we do have a more rule-based system that generates a contextualization, but on top of that, we're building a capability called AI SOC Copilot that's using generative AI and large language models. So which again is trying to explain to the security analyst the vast amount of logs that are generated by the devices in just like in a few paragraphs. So we also do automatically push that contextualized alert data to the security team when it's something that's suspicious. So that's where we are doing some of the noise filtering and doing a lot of automation around that. We also use ticketing platforms and emails, so the output can be pushed via those different systems. And we've developed our user interface, so AI SOC user interface, in order to visualize all that data. And we've mentioned before that it's important to have a human in the loop, or to have a security analyst in the loop. And in that regard, we do gather user feedback, and that will enhance the future predictions that's taken into account in the future predictions that are made. So in terms of some of the benefits that we've achieved with AI SOC and Logpoint, so we are processing every single alert with AISOC. So every alert that's generated in Logpoint, or every incident that's generated in Logpoint, we extract it and we process it in under about 20 seconds. We've built a centralized view of the alerts that's also multi-tenanted by design. So if MSP or an MSSP has multiple customers, well, they would have multiple customers, then they can see the different customers on a single platform and filter it easily. We've on the latest data or benchmark that we've run, we saw on average about 80% reduction in alert volumes. So that's the non-suspicious, the false alarms that are filtered out by AISOC. And we've also seen that the remediation time has been decreasing by 30 to 40% because, well, cybersecurity analysts have the investigation information or the contextualization information straight away available to them. We also have about 94% accuracy on the predictions that are made by AISOC. So by the machine learning piece combined with statistical calculations, we do escalate the false alarms that have a low degree of confidence. So if AISOC isn't too sure about one of the predictions, we do escalate it for and flag it for human review. But we are working on improving our accuracy towards 99% plus. And well, overall, we've seen a significant improvement in terms of analyst productivity and the fatigue, so less fatigue from analysts.
You have even an example from an existing customer, right, where you have reduced the false positive rate by over 80%, and also the mean time to detect went from hours to seconds. That is literally how you can see the significant improvements and how they are, how they have operational impact. And I can just relate to that, and it's very good to see those numbers, and especially also with the accuracy of the predictions going up, that will help building more trust on the technology as well, right?
Yes, yeah, true. So we do use AISOC internally, since when I say internally, I mean on the MedCloud side. But we also, for our own data, but we also use AISOC, as you mentioned, with some of our customers. So MedCloud customers, and as you've said, we've noticed significant improvement and output with them indeed. So now in terms of implementation roadmap and best practices, I think it's important to first look at data readiness. So it's always important to first making sure that your logs, alerts, and workflows, knowledge bases are all comprehensive and clean, since machine learning or large language model performance would depend on it. So you need to have clean data. And once you have clean data, you can work on implementing either machine learning or large language models or both. So once you have that, the second step we recommend is to identify the high impact use cases. So beginning with tasks that are time consuming or repetitive. For example, if alert triaging and alert investigation is taking a significant amount of time in your organization, that's where that's the use cases you can pick. And once you have those use cases, then the next step is identifying the right tools for the job. So if it can be a use case that's solved by a rule-based system, actually maybe you don't even need machine learning or large language models. You might just have some automation that only uses a rule-based system and a very simple workflow that would save you a lot of money, time, and effort. But if it's not something that can be solved by a rule-based system, then do you need to use machine learning or large language models? We've talked about the difference in the past slides. And then, do you have the resources to implement these tools in-house, so in your organization, or can you leverage an existing solution for those use cases? So of course, if you have the team that can handle, or like for example, data scientists or software developers in-house, then you can try to look at implementing that in-house. But then if you don't, then that's when you can call other, you can try to use external providers, such as AISOC, for example. And the next step is to, well, building trust with your users and your team or customers and organizations. So of course we mentioned that it's important to ensure transparency. So analysts and customers need to understand why AI, in quotes, is making certain recommendations. So the right controls and guardrails need to be set up based on responsible AI for generative AI and explainable AI for traditional machine learning wherever possible. So there would be, I guess that this responsibility lies with either the software provider or the company that is providing this service to you, but it also lies in the organization that's using the service. So making sure that, for example, the data that are fed to the machine learning or large language models are sanitized, or make sure that they don't include sensitive information that you don't want to leak anywhere. And so with AISOC, we are partnering very closely with SOC teams to identify where AISOC can deliver, where AI can deliver measurable value first. So building momentum for a broader adoption in the market.
That is very good to hear, and thank you also for sharing this that open. It's a thoughtful approach, making artificial intelligence an enabler, not an obstacle, and it's about the measurable impact and not the hype. So that's what I really like. But also brings us to the end of that session. So on behalf of Logpoint and AISOC, thank you very much for joining us. If you'd like to learn more about AISOC and the platform behind it, you can visit aisoc.cloud. Or reach out to Javier. And if you want to see how Logpoint can help to unify and automate your SOC workflows, you can also visit logpoint.com or reach out to me directly. And thanks again for spending time with us, and stay secure.